Hi. So now let us see the second normal form. So which is one of the important normal form actually. So what is this second normal form? So simply first of all definition wise, if any relation is in the second normal form, how it will be says, first of all it must be in the first normal form. That is as usual actually. Here very important thing is every non-primary key attribute is fully functionally dependent on primary key actually. Okay, so here we already discussed that in the last lecture in the functional dependencies concepts. We discussed that partial functional dependency, and full functional dependency. So he is talking about this one actually. So every non-primary key, every non-key attribute fully functionally dependent on primary key actually. There should not be any partial functional dependency. So you are going to have set of FDs, right? So each FD you have to cross check that whether it is full functional dependency or not. If every FD in that set is full functional dependency, then we can say that is in the second normal form. Otherwise, if there any partial functional dependency, then we can say it is not in the second normal form actually. Let us take a simple example. For example, this is what your primary key, where you have set of attributes. Assume that a primary key have more than one attribute combination. Then if you take any non-key attribute, so primary key is going to derive completely this non-key attribute. So that is what full functional dependency we can say. So another non-key attribute also, if you take every non-key attribute, you are in a position to derive with full functional dependency actually. But sometimes what is going to happen? So for example, our key is AB assume, for example, for better understanding. So that means our key is this one A and B. So some attributes, for example, so attribute C, you are deriving by using both actually A, B. So that is going to become full functional dependency. But some attributes, if you see, by using, for example, attribute D is there, we are deriving by using B only. That is why it is coming from inside. This meaning is both. And some other attributes are there, that is you are deriving by using A. So this is partial functional dependency. That is what I try to understand. So this kind of FDs should not be there to tell you if it is in a second normal form. So B deriving some attributes separately, A deriving some attributes separately. That is what actually prime attributes separately deriving some other attributes, non-key attributes. All these are non-key attributes. So this kind of things are not allowed. If all FDs are like this, then that is in second normal form. If some FDs are full and some FDs are partial, then overall relation is not in second normal form. So the whole discussion for better understanding, let us take one simple example here. So you can see here patient and a drug table. This table name is patient drug table. Here we have a patient number, drug number, and how many units of drugs you have to give for that particular patient, and what patient name we have here and drug name we have here. So what is our observation here? You see patient 1, if you observe, patient 1 is Krishna. So this is what redundant data we have actually. So that is what meaningfully try to understand what is meaning of partial functional dependency. You have a lot of redundancy actually. And drug also, if you see drug D1, drug D1 is Dolo, drug D2 is paracetamol, D3 is crocin, D4 is Niftel. And D3 again repeated. So that is what crocin. How many times D3 you have, that many times crocin you repeated here. So that is what redundant data is there. Ultimately, that you have to reduce actually. So that is what here primary key is what actually. So let us take the FDs also, set of FDs. So these are the set of FDs we have. So that means what is the key actually here? So key, how you will find, we already discussed it. Closer, try to find out actually. So let us take the P number and drug number, which we don't have RHS side. So P number, drug number, it's a closer. If you find what we are going to get. So we are going to get, of course, P number, drug number, and P number, drug number deriving number of units. So I'm just taking NU, number of units, and P number deriving P name, and drug number deriving drug name. So that means what actually? All attributes derived by using these two. That means key is these two. So that means primary key of the table is these two. And you see in the FDs actually, this is deriving. So that is what our example here you can see. So for example, this is the P number and this is the drug number. Yes or no? So drug P number deriving P name and drug number deriving drug name, and together deriving number of units. Is it or not? So you see here A separately deriving. Because of this derivation, you have separately lot of redundancy is there in the table. Krishna, you repeated how many times? How many times patient 1 is there in the table? Or even the drug also, how many times you repeated, how many times that particular drug number is there. So this kind of things are not allowed. So what is the solution? That is important. So now the solution is, this is of course full functional dependency, and but this is P number is part of key. So this is partial functional dependency. And drug number is also part of primary key. So that means this is prime attribute. So this is also partial functional dependency. Take every partial functional dependency one by one. LHS side, whatever you have, that is what P number. First of all, if you take this one, find its closer. So P number, and what we are getting, P number, P name. So closure of LHS of this partial functional dependency P number is giving this one. So make this one as a separate table. That is what. And another partial functional dependency is this one. So what you have LHS side, drug number. So take the drug number, find its closure. So drug number deriving what are all attributes? Drug number deriving drug name. So that's it. It is not deriving anything else. So that is what. Now make this one as one relation, make this one as another relation actually. So that is what you can observe that. So this is one relation, this is another relation, and original table patient drug. So patient drug, what we are going to have. So patient drug table, we are going to have, of course, primary key will be there, P number, drug number. I'm just writing shortcut. Now here and here not covered attributes are what? In this and in this, not covered attributes is number of units that we are going to have here, number of units. So totally it became 3 relations actually. So that is what you can observe here clearly. Patient. So the first one is patient number and patient name. That is what here. So patient number is the primary key here. So you can see 2 patients are there overally. So only 2 rows we have actually, and their names Krishna and Rama. And another table is what actually drug table. So drugs, how many total we have? 4 drugs we have. So the 4 drugs. So that drug number is the primary key here, and their names we have here. And now the original table is this one, patient drug table. So you can see that. So patient number and drug number is same. If you observe, number of units is not covered any one of the relation actually. So in the original relation, what attributes you are going to place actually? The attributes which are not covered in any of the closure. Those attributes are going to there in the original table. So now you can see actually patient number 1, Krishna, is not repeated. that is redundant data. This much redundant data we are able to avoid. And the same way, drug also we are able to avoid actually. So part of the primary key, that means prime attribute, if it is deriving some other non-key attributes, it's better to decompose it's better to divide the table so that you can reduce the duplicate values actually. Lot of redundancy you can reduce so that update anomaly you can avoid actually. Suppose if you want to change the name of the patient 1 to some other name, then wherever it is there, in all places you have to update actually. But now just to update here, instead of Krishna, some Ravi if you want to place, then that's it. This is the only one place you have to update. So update anomalies are avoided actually here. So that is what actually, especially in the second normal form, prime attribute. Okay. So if in the primary key, what are all attributes are there, calling as a prime attribute. If prime attribute deriving any non-key attributes, then find the closure of that prime attribute and make it separate table. That's what simple solution to make in the second normal form. Now all these three tables are in the second normal form. So that is what this single table became now 3 tables actually. Okay.